So this is question 10-2. For part A, you need to use Gauss's law, which is the integral of E dot dA, which is equal to Q over E. Permittivity is equal to the dielectric constant times epsilon naught. So Q over the dielectric constant K times epsilon naught is equal to E times the area, which is 2 pi r L. So E is equal to Q over 2 pi dielectric constant K epsilon naught r L. For part A2, you have to use Gauss's law again to find the space outside the outer shell, which is just E0. So E is equal to 0. Okay, B I. You need to find an expression for electric potential between the two shells, so you use triangle V equals VB minus VA, which is equal to the integral of ER dr from A to B. You then have to substitute the electric field between the shells, which we found in A1. So triangle V is equal to Q over 2 pi dielectric constant K epsilon naught L times the integral of dr over r from A to B. So the electric potential difference between the shells is triangle V equals Q over 2 pi dielectric constant K epsilon naught L ln B over A. Now to do B part 2, we need to compare Q and V. So C equals Q over triangle V, and we got triangle V from the above answer. So C is equal to Q over 2 pi dielectric constant K epsilon naught L times ln B over A. And we simplify this to C fix that. Simplify to C equals 2 pi the dielectric constant K epsilon naught L over ln B over A. And that's the answer. Now we gotta do C part 1. We need to use Ampheres law, which is the integral of B dot dl, which is equal to mu naught I. Now we have to substitute the current through the inner shell. So B times 2 pi r is equal to mu naught, and I is M's over r. So the magnetic field between the shells will be B equals mu naught F over 2 pi R over resistivity. For part 2, you multiply B by 2 pi R, which will equal mu naught 4 F over the resistivity. So the answer for the magnetic field around the outer shell should be B equals 2 mu naught M over pi R resistivity.